Okay, so I'm back, and here we are applying the constant multiple rule. So we have finding the derivative. So the one thing that's kind of funny about this is if you look at the function, students have to remember that this is actually, when we write this, it's just negative 3/2 times x. So you see the constant negative 3/2 out front. So we have y prime is equal to negative 3/2 times the derivative with respect to x of just x. So the derivative with respect to x of x is just 1, so we now have y prime is equal to negative 3/2 times 1. So we get y prime is equal to negative 3/2. For part B, there are times where you see the pi involved, and you have to remember that pi is just a constant, so we have y prime is equal to 3 pi times the derivative with respect to x of x, and so it's just going to be y prime is equal to 3 pi times 1, or just 3 pi. And it kind of makes sense when you look at this because the slope, the derivative is the slope. So when you look at the equation, y is equal to 3 pi x, the 3 pi is just the m, or the slope of the linear equation. And then for part C, we have y is equal to negative x over 2. So we could write that as negative 1/2 x. So we would have y prime is equal to negative 1/2 times the derivative with respect to x of just x, and that would of course be just negative 1/2 times 1, or negative 1/2. Okay, so sometimes we want to emphasize this rewriting aspect so that we don't mess up the derivative when we have exponents that are in the denominator, or powers are in the denominator. So we have 5 over 2x cubed for our first function, and to find the derivative, we very often want to say that, well, this is y is equal to 5/2, and then make this x to the negative 3rd power. So when we do that, it helps to calculate the derivative a little easier by saying y prime is equal to, we keep the 5/2, and then we just multiply by negative 3, bring the negative 3 out front, and using the power rule, and then we just lower the exponent by 1, which makes it a negative 4. So we simplify that, and we get y prime is then equal to negative 15. I'll keep the negative out front, negative, put the 15 in the top, and it'll be 15 over 2x to the 4th power. There you go. Now, which is different from the next example where the denominator is in parentheses. So you have 5 over 2x, the quantity cubed. So that's going to be an 8x cubed in the denominator. So then we have y is equal to 5 over 8, and it would still be x to the negative 3rd power. So using parentheses when you're differentiating kind of helps to separate the constant that you're pulling out front from the part you're going to take the derivative of. So you have y prime is equal to then 5/8 times that negative 3x to the negative 4 power. And so your final answer here is then negative 15 over 8x to the 4th. Okay. All right. Now for the next one, we have 7 over 3x to the negative 2nd power. So why don't you pause your video and try C and D and see if you can get the answer. And then restart it to check. Okay, so for the rewrite, what I would do is say, I'm going to pull the 7/3 out, make this y is equal to 7/3, and just then x squared. So you have an x to the negative 2nd power in the denominator, and that goes to the numerator as x squared. So now that I've done the rewrite, then the y prime is 7/3 times 2x. So the final answer is going to be 14x, and I'll just put that over y prime is equal to 14x, and I'll put that over 3. For the last one, where we have y is equal to, this would then be 7. Now you have to watch, your 3x to the negative second power is really going to be 7 over 1 over 3x squared. So it's actually going to be 7 times the quantity 3x squared. So let me write that right here. 7 times 3x, the quantity squared. So this is going to be 63. That'll be 9x squared. So it'll be 63x squared. So it'll be 7 times 9x squared. So when we do the derivative here, the y prime is then going to be 126x. I actually could put that over here. Okay. Okay, so for here, I'm just going to put 63 times 2x. Okay, so using parentheses when differentiating and finding the derivatives. So note radical expressions can be rewritten as rational exponents as well. So what we want to do is differentiate radical functions using the rational exponents, so we can use the power rule. So the first thing I would do is, if I want to find the derivatives here, the first one is y is equal to the square root of x. I would rewrite as y is equal to x to the 1/2 power, and then define the derivative, y prime is equal to 1/2 x to the 1/2. I'm going to write 1/2 minus 1 here just because sometimes it can catch people. But 1/2 minus 1 is then negative 1/2. So that when you rewrite this, you're going to get y prime is equal to 1 over 2. And I'm going to write it as x to the 1/2 in the denominator, but then we usually, I wouldn't say proper, but usually people write that as the square root of x instead of x to the 1/2 power. More commonly written, at least. Okay, so then we have our next one is a rewrite of. So whenever you have these radicals, you want to think to rewrite as an exponential power. So I would rewrite this as y is equal to 1/2. The 2 is just 2. And then it's 1/2, and it's x to the negative 2/3 power. Okay, you have an x to the 2/3 in the denominator. So if I take it out of the denominator, it becomes a negative. It's positive in the denominator. It's negative when I take it out of the denominator. So now, completing the derivative, I have 1/2 out front, and then it's going to be times a negative 2/3 times x to the negative 2/3 minus 1 is negative 5/3. So now, simplifying the expression, we would get y prime is equal to, y prime is then equal to negative 1/3 x to the negative 5/3. And let's change that so it's positive. Sorry about that. So it's going to be negative 1/3, negative 1 over 3x to the 5/3 power. And then for the last one, C, I would rewrite the whole expression as a power to the 1/2. So it'll be 2x, the quantity, to the 1/2 power. And then that's going to be the square root of 2x to the 1/2 power times x to the 1/2 power. So now I'm going to do the derivative. Y prime is equal to, I'll keep the square root of 2 out front, and then I'll multiply it by 1 over 2, x to the negative 1/2 power. So then my y prime in simplified form would be root 2 over 2. So it would be root 2 over 2. I think I want to simplify this differently, though. 2 square roots of x, but I could write it a little bit differently. I kind of like it like that, though. We'll leave it. Alternatively, I could have written it like this. Y prime is equal to 1 over square root of 2x if I wanted to. Square root of 2x. But you have your choices there. Okay. So now you have your difference, your sum and your difference rule. This is pretty intuitive, but worth noting though. If you have y is equal to 3x plus 2x cubed, then you can probably guess that if we're going to find y prime is equal to 3, the derivative of the 3x, and then just plus 6x squared. That would be the derivative of, I should put a d here for derivative, of the first term. Okay, so if I am going to be taking derivatives, and I'll finish example 8 and then have to pause the video. So let me see if I can finish this one. Using the sum and different rules, we can just go left to right. So we get y prime is equal to, it's our first one, 3x squared plus 8x. So just dropping the exponent by 1. Okay, bringing the exponent around front and then dropping it by 1, bringing it around front, multiplying it by 4, dropping it by 1. For the next one, we would have f prime of x, since we're in functional notation there. And then I'm going to bring the 2 around, multiplied by 3 to get 6x, and it's then lowering it 1 is just 6x to the first power. And minus 2, there is a 1 here, 1 times 2, so it'll be 2 times 1, which is just 2. So then we have another one we're going to do a rewrite with. We're going to say it's 3x squared over x if we divide this whole thing out. So we'll divide each terms divided by a monomial. So we get y is equal to 3x minus 1 plus 1 over x, which is x to the negative first power. So then we have y prime is equal to 3 is the derivative of 3x minus 0, and then it's going to be minus 1x to the negative 2 power. So the derivative of x to the negative 1 is right here. Okay, and so simplifying that, then we get y prime is then equal to 3 minus 1 over x squared. And I could write that differently. I'm going to leave it like that for now. I'm going to come back and I have a couple more examples to finish, so I'm going to stop this video and I'll pick up with video number 3 for section 2.2. Bye. Have a great day.